Thank you. So yeah, I saw some feedback from a couple of people. Looks like they managed to complete the exercise, so that's good. That's good news. And let's take a look at my screen, and I'm going to start coding because that's what I'm here for. Show you this solution step by step. And as I do that, I like to give you a bunch of tips and tricks. So I hope you'll get maximum value out of this solution. And yeah, I'll do it as slowly as possible, but slowly in a good way, not in a boring way, trying to add information and really go step by step. So as a reminder, what we're trying to do, we have this currency dropdown. We want to be able to select a new currency. And when we select a new currency, we want these prices and the currency symbol to be updated. And we're going to do so using a service. So currency service was already there for you. And so yeah, I'm going to start there. So as we mentioned before the exercise, a signal is a way to store a value and then share that value between multiple subscribers, if you will, multiple different components. So we want to share a signal that's going to store a currency. So let's create a currency property here, and it's going to be a signal. And in our case, the application by default is displaying prices in US dollars. So what I'm going to do is just assign USD as the default value. And of course, I have to import signal from Angular core. And there you go. I have a signal that stores the value USD, which is good. This would work. This would store the value for me. But I can do a little bit better with this. And the problem that we have here potentially is that because I'm using USD as a value, this signal thinks that it's a signal of string, any type of string. And that's not really true. We want to make it specific to currencies. So the nice thing about that signal function is that it supports generics. And so right here, I can insert those brackets and specify that it's a signal of currency, making everything a lot more precise now. Because if I try to change that default value, you'll see that my IDE can autocomplete and suggest the three possible values, which are USD, Euro, or GBP. So that's my first tip. You can be more precise with the type using the generic syntax here. And that way, Angular knows that this currency is a signal of type currency. For your info, this currency type is defined in a different file. And all it is, it's a union type between three different strings. So created a type out of these three strings, union of these, so it's one or the other. And there you go. We have a signal that can store that currency. So what we could do with this is that right now my signal is public. And I can use it as is in my other components. So other components could set a value, update the value, read the value, all of that stuff. Thing is, it's usually a good idea to keep that more private, right? So to keep the signal sort of private, and then only expose an API to set and read that signal through the service, so that if we have side effects to run, or if we have some other business logic to take care of, the service can do that. So that's what I'm going to do now. So implement a way to store the currency as a signal. That's done. I can remove that to do. But I want to make this private. I want to make sure that nobody can access it. And a little add-on, not 100% required here, I could also make it read-only, just to ensure that in my service later on, we don't reassign another signal on that currency. We always use the same objects now. So it's private, it's read-only, meaning I can only manipulate that object through its methods. I cannot reassign something new to it. Now we want to expose this signal in a read-only manner. Okay, so let's add a getCurrency method, which is going to return a signal of currency. And in here, I'm going to use my private signal, so this.currency. But instead of returning it as is, I'm going to call that extra method as read-only. And when you do so, it exposes a read-only signal. That way, I know that my components can only read the values from that currency and not change it. If they change it, then we'll have to provide a different setter for that, which is one of the next to-dos. So get currency, return the signal of currency, we expose it as read-only. Perfect. And by the way, if you have any questions as I do this, feel free to use the proper Discord channel. So there's a specific one in Frontend Nation Forge, the architecting Angular apps with signals. I have this open on my other screen. So if I see questions pop up in here, I can answer them live, right? So feel free to use that if you have any questions. So we have a signal. We have a way to expose it in a read-only manner. So I can remove that to-do. Perfect. And then we want to expose a public setter for components to update the current currency. OK, so let's create a set currency. Takes a currency as a parameter. It won't return anything, so I can make it return void. And in here, what I want to do so far is just change the value of my signal. So this.currency.set of the new currency. And this, of course, is public. So these two are public. So now we have a public setter for components to use. And that would be my basic, very basic currency service that only takes care of the currency symbol for now, not the exchange rates. That would be really, you know, the bare bones implementation, the strict minimum we need to handle that currency. Of course, it can be done in different ways. The only reason why I do it this way is to give you those extra tricks, such as private, read-only, exposing a signal as read-only, and that way we kind of secure the access to that signal by adding extra controls on top of it, which is always a good idea in terms of architecture. That's currency service. Now that it's done, or at least this part of the service is done, I can use it in my currency switcher component. So let's go to currency switcher component.ts, where we inject currency service. And so when we change a currency, we want to change it in our service. So using the setter we just created, I'll do that. This.currency, Mr. Service set currency. There you go. That would do the work. And in my template, so this method is called whenever we select one of the drop-down options. So let's see if that works. Going to my browser, going to open the DevTools here. I select a new value, and nothing seems to happen. Why is that the case? This always displays USD, even if I clicked on Euro. So let's check why. I'm going back to my code. And in that template, we see that we have an expression up here, but it always displays USD. So that's why. We always display hard-coded USD in here. That doesn't help. So what we are going to do instead is, so I'm going to split that screen in two. Oh no, let's just keep it here. And here we have our service. So I'm also going to have access to our currency. And I'm going to do this dot service dot get currency. So this is going to return our read-only signal. And give us access to it through this property. So now that I added that line of code, I can go to my template and read the value from that signal using currency as a function. Let's check that it's working now. Going back here, I select euro, and the button says euro. I select GBP, the button displays GBP. So pretty good, right? We can tell that things are working. If I wanted to check what the service is doing, another option we could have is to use the Angular DevTools. So if I open the Angular DevTools in here, so it's a browser extension. You can install it from the Chrome store. And I would select, let's say, my currency switcher component. This gives me access to the currency service. And we can see the signal as well. So currency is a read-only signal with a value of GBP. So I can explore my service and see what's inside of it. And so when I change the value to euro, I can tell in my DevTools that the service was properly updated, and in its currency is a signal that stores euro right now. So these are some nice tools we have in the Angular DevTools. So we don't even need a debugger, breakpoints, or anything like this. We can have a live view of what's going on in the application thanks to the components view of that extension. All right. So far, so good. We are on a good path. We can update the value of our currency. Now we want to play with the exchange rate. We want to handle the change of exchange rate, well, the exchange rate to apply when we change the price, right? When we change the currency. So how do we do that? The first thing we know, and the good thing with signals is that we can really go step by step, right? We don't have to try to figure everything out up front. We can really declare what we need step by step and then decide how to combine that information. So what do I need to apply exchange rates? Well, first, I need the exchange rates themselves, right? So I'm going to create a property that I'm going to call exchange rates. And this one is going to be an observable, right? We have to make an HTTP request to the server to get the exchange rates. So if I make an HTTP request, I need the HTTP client. So let's inject it. And once I have the HTTP client, it's going to be a GET request to the URL provided in the instructions. So I'm going to copy paste it. This one, copy, go back to my IDE and paste. And so that's my observable of exchange rates. Now, what we get from that endpoint, we can take a look at it by just opening it in a browser tab. So you see that it's a simple object with the exchange rate for every currency. So from USD to GBP, exchange rate is 131. From USD to USD, it's 1. And from USD to Euro, it's 1.14. So that's the basic structure of that object. Now, when we work with data from a server, it's always a good idea to have type information for that data. And so we're going to create a type for these exchange rates, which in TypeScript can be done in a couple of different ways. So one option, probably the most intuitive and easier to understand, would be to say that our exchange rates are an interface, and it's basically mapping from euro to a number and GBP to a number and USD to a number. All right, that's what exchange rates are. Thing is, that type is kind of as if we are coding the three different currencies. If we add another one in the future or remove one, then we would have to remember to update that interface, which of course is error prone and never a good idea. When we write code, we want to architect things in a way that is resilient and that we know it's going to scale in the future. So what we can do instead is that there's a TypeScript utility type that we can use. And that utility type is called record. And with record, you can say that you are going to map a specific type to a specific value. So if I do this and say that exchange rate is a record of currency to number, it's exactly the same thing as the interface we had before. So you can see down here, WebStorm is telling us that the resulting type is USD number, GBP number, and Euro number. Good thing about this is that if I add a currency later on, this type is also updated. So record is a very good tool for that. It's a very good utility type to make things more expressive more easily. So that's another tip. And now that we have that type, we can specify, just like we did for signals, and we say that our signal is going to be storing a currency. I'm going to say that my HTTP request here returns exchange rates. And that way, the compiler knows that this exchange rates $ is an observable of exchange rates. Now, we don't want to deal with observables. We make that guy private. It doesn't have to be visible outside of that service. And what we want to do is turn it into a signal instead. So I'm going to add another property, and I'm going to call exchange rates without the $. And for this one, just going to do a conversion using toSignal. And I'm going to convert into a signal this .exchange rates $, which is going to turn the observable into a signal. So it's basically going to subscribe to that observable, get the data, and then store the data inside that signal. Now, if I do this, the type of that property, as you can see from the compiler, is signal of exchange rates or undefined. And that's because the observable is going to take some time before we get the data, or there could be an error or something. And as a result, the type of this at this point is exchange rates or undefined, which, when we have undefined, it means we have to do extra checks. Do we have the data or not? If we want to make our life easier, we can provide an initial value, which I'm going to do here because I can do that. And I'm going to say that the default value, so the temporary value to use before we get any data from the server. And it's almost cheating a little bit, but I'm just going to say that all of the exchange rates are 1 in that scenario. And since our default currency is USD anyways, the exchange rate would be 1 for it, so it doesn't really matter. And that way, just by providing that initial value, now my exchange rates signal always has something. It's never empty, and it's going to have data no matter what. So now we have our exchange rates, and we have our current currency. What do we need to do with that? We need a way to return that value to our components. Our components that display prices, they need to know what is the current currency and what's the exchange rate that goes with that. So in a sense, instead of returning just the currency, what we can do is change that getter a little bit. And let's say that we are going to return currency info instead. So this is not going to be a signal of currency anymore. It's going to be a signal of currency info. And in that currency info, I'm going to combine the 2 pieces of information. So let's read the type up here. And I'm putting my types in here just so you can see them all the time. I don't recommend creating interfaces and types in a service. It's just for visibility, and so you can see what the types are all about on one screen without having to share too many things. So we call this currency info. And in currency info, we are going to have the current currency, of course, which is going to be of type currency, and the exchange rate that goes with it. And that's going to be a number, because that's the information that our components need, right? They don't need to know about all of the exchange rates or all of the currencies. They just need to know what's the current stuff. What do I need? What's the current currency and exchange rate? That's all they need. So we're going to expose that as a signal. And that way our components can consume just that piece of info. Which means we need another signal. Because now we have our signal that stores the currency. We have the signal that stores the exchange rate. And we need a new one that combines these two things. And as we saw in the intro to the exercise, I mentioned that there's another utility function in the Signals API, which is called computed. So now I'm going to create a new property, call it currency info, and this is going to create a computed signal. So computed takes a function as a param, and in that function, we are going to create the new value out of our other signals. So in my case, what do I need? First, I need the exchange rate. So let's say I'm going to declare exchange rate. And so where does the exchange rate come from? It comes from the exchange rates signal, which is going to return that object. And inside that exchange rate signal, we want to read the value that corresponds to the currently selected currency. So something like this, reading the value from the exchange rate signal and reading the property for the currently selected currency. So we use two signals in ones here to get that number. And once we have that number, we can return our currency info object, which is a currency. So currency is going to have the value of our currency signal, and exchange rate, well, we just defined it here. So I can just use it as is. And that's my computed signal. I can specify, so just like everything else with signals, I can use a generic type to say that this returns currency info, just to make things more precise and more accurate. And so we have it. There we go. We have our currency info signal. So we can now return it from here. And this one, we don't need to turn it into a read-only signal because it already is read-only. Computed is read-only no matter what, because it's computed by Angular and the Signals API, so we don't have, we cannot write into it. We can only change the input signals, the dependencies that trigger those changes, but we cannot change the value of computed itself outside of that function. So we can return it as is, and we're good to go. So with that in mind, I think our currency service is all good now. Can remove the last to do, and I think it has everything we need. So let's check it out. So first, I think my code is broken. The compiler should be unhappy with what I did here. Yes, it is. And that's because if we go to currency switcher, here we read the currency, and get currency doesn't exist anymore. So I have to call this get currency info. I'm going to call this currency info as well. So I change the type and the name of the method of the getter. And in my template now, this is going to be currency info. dot currency. So reading the value from a signal, and then because we have initial values for these two signals, the computed signal always has a value, so we don't need the question mark here. We don't have undefined. And that's one of the benefits of providing default values to those signals. We can get rid of undefined values, which makes the rest of our code a lot easier to read and to understand. So does this still work? Let's see. I'm going here. I'm going to select euro, and it stays euro. So looking good. If I go to my view, currency info has a currency of euro and an exchange rate of 1.14. And same here. So we can see the values of our signals. Everything looks good. We got the exchange rate from the server. The current currency info is euro, is an exchange rate of 1.14. So this is all accurate. Let's change it to GBP. Exchange rates, currency info. Oh, it doesn't want to open anymore. What did I do? Okay, DevTools, maybe we found a bug. Maybe because I'm too zoomed in. Yeah, it doesn't want to show the value anymore somehow. Let's refresh it just in case. And we select euro, go here, service. Yeah, so euro 1.14. Let's select GBP, signal of GBP, currency info. Okay, it doesn't like when I change the value, but I can tell it's working. So far so good. We have all of the pieces, which means that the last thing to do is to get those license plates to read this new currency info and display it, right? Apply the exchange rate, apply the right symbol and everything. So let's go to license plate component now. So license plate component has two inputs, one for the license plate, one for the button text, which means at this point, it's a presentation component. And presentation components are good because they are independent from services. So I could inject currency service in here, but that would make that component not a presentation component anymore. So what I'm going to do instead is say that currency info is also going to be an input. But I'm going to, since this is a workshop on architecting with signals, what I'm going to say is that, or not currency info is the name, and it's an input. And I'm going to say that it's a signal input, because that's one of the other new things we have with the Signals API. We can have signal inputs for everything. So I'm going to make this an input of type currency info. And since we're doing it for currency info, why not migrate everything to signals here? So I'm going to use the same idea for button text and say that it's an input of. So this was not required in the exercise. This is just some bonus that I give you, some extra info to make really everything 100% signal compatible and using the very latest features of the Angular framework. So yeah, now these three inputs are signals. What does that change for that component? From a syntax perspective, not much. We would still use it the same way and pass the inputs in a similar manner. The only difference is that those inputs can be just a value or a signal now, and both options are supported. What would change in our template, though, is that now we have to read those signals. So we are going to do something like this for all of the places where we read those properties. And again, you didn't have to do that. It's a bonus, so don't worry if you don't have this in your code. That's perfectly fine. Oh yeah, so plate is possibly undefined. What I can do to prevent this is to say that this input is required. So there's an option with signal inputs to make it required. Like so, input.required, and let's say it's going to be the same for exchange rates. I'm going to make it required as well. And that way, all of these warnings go away, and the compiler is happy, because if we don't pass a value, it doesn't compile. And this component does need these two things, otherwise it cannot work. So we made those inputs required. So inputs are there to get the data. Let's now go to the component that's using this, and that's store view component. Store view component HTML is where we have app license plate. And so in here, we want to pass that currency info. And we have to get it from a service. So inside that store view component, which is a container component. So this one already has an HTTP client, is already interacting with a server and services. Here I'm going to inject, well, I'm just going to get the currency info directly by using the inject function, currency service dot get currency info, so that I don't need that service for other things, just to get the currency info. So I can do it all in one line of code. And that gives me my currency info signal. And now that all of this is in place, I can go back to currency, no, license plate component, yes. So currency info, oh no, the template first. Store view component HTML. Here we pass currency info as an input. There you go. We pass the value as an input to the license plate component. And as a result, license plate component is going to receive that value. It's so when a signal is when a component is like this and only relies on signals for everything, this is what we call a signal-based component. And this is very important because in a near future of the Angular framework, there's going to be a fully optimized change detection mechanism for signals. It's actually out in developer preview right now in Angular 18, but it's just a preview and it's very experimental. But it's out there and it's going to become stable very soon. So doing this helps us create a signal-based component, which is going to be the future of how we architect things with Angular and signals. So it's important to do it that way. So we have a signal-based component. Now let's use that new currency info. Going to license plate component HTML. So we have the price. We have the $sign here that I'm going to remove, because instead we are going to apply the currency pipe from Angular, and we are going to pass the currency as a param. So that currency comes from currency info dot currency. And that way it's going to do the right formatting using the proper currency symbol and applying it to the price. And the other thing we have to do is apply the exchange rate. So our price, we can multiply it by currency info dot exchange rate, just like that. And you see that now we have signals everywhere. All of that is reactive. All of that is optimized for change detection and signal-based components. Let's go to our app, make sure we didn't break anything. And maybe we did. Oh yeah, I changed the other component, but we don't use it, so that's fine. Let's change the currency. Euro. Oh, it actually didn't work. Yeah, I have to pass currency info in another component, in another place where we're using license plate, which is card view. So to make things easier and not too confusing, what I'm gonna do is remove those plates from there. And I stretch things a little bit. You didn't have to do that in the solution, so don't worry. Oh yes, and my button text is also a signal now. So we have to read the value. And now we should be all good. Yeah, prices are in USD. I go here, select euro, euro 12.54. I go up here, select GBP, and British pounds 14.41. So the exchange rates were applied to our prices. It's all reactive, it's all signal based. And in the process, we covered quite a few interesting things, right? We saw all of the common ways to use signals. So the signal function, the toSignal function to convert an observable into a signal, computed to derive a value from a bunch of different signals. We saw the read-only option to turn a signal into read-only. We saw signal inputs in our license plate component, which was really a bonus, but that made our component fully signal-based here. And that was the exercise before the bonus. Again, if you have any questions, feel free to ask them in the Forge, not in the Forge, in the Forge channel on
All right. That's
I'm
fantastic.
trying to look if there's any questions out here, but looks like
we get a few questions. Okay. Yeah, I'm going to show you these questions. But yeah, fantastic. I was following, and it's mesmerizing. I can't stop, watching you teaching stuff. It's really good and easy way to do that. To be honest, it's been a while for me. I'm not writing Angular on a daily basis. I'm writing different things. But yeah, I miss these days. And you, kind of teased me to get back to Angular, try it out, and yeah, the code is not changing that much, but the signal part is really in a good way done. Observables was quite challenging in the past.
tricky.
With
Yeah.
yes, yeah. Cool. So we have the first question is coming to us. Can you show another example of making the signal type safe?
So making the signal type safe. So let's go back to my service, currency service.ts. So the main way to have that type safety is to do that thing, right? To use the generic syntax on any function, which is, so signal, toSignal, computed, all of them support that. And that's how you make all things type safe. I could also do it here. So this would be a signal of exchange rates. Actually, the compiler can guess that one, so it doesn't really need it. But yeah, that would be the way to do it. You just pass that in here, and then you're good to go. You have type safety, which you can make even more explicit by repeating it here. But the compiler doesn't need that. The compiler already knows that this is a signal of currency thanks to the generic syntax here. So I would stick to making it as short and easy as possible. And so yeah, this works. This does a job.
Yeah, it's just by passing the it as a generic for it, so it can be generated as a type. Yeah, most probably. Also, I like the way that you explained that instead of using interfaces, we can use also the utility of doing a record. It's really useful and handy. During your implementation with interfaces comes to my mind, why you didn't do it in record? But in the same time, just 1 minute later, you were just, building it up to use record. It was really good. Yeah, thanks for that. So the next question is, what will become of observables in the future? Is it going to be...
That's a very good question.
Yeah.
So for now, observables are still part of Angular, but there's a plan to change as many APIs as possible, so they're not based on RxJS anymore, and we have an alternative using signals. That's already the case with outputs, for instance. We saw in our license plate component, we have the input function. There's the same thing for outputs. And the new output is not based on RxJS anymore. The old one was. The new one is just an output that doesn't use observables. So that's a first place where RxJS was removed, in a sense. And the Angular team wants to keep doing that in forms, in the router, in many different places. We are going to see new APIs that are signal-based instead of RxJS-based. So the plan in the long run is that you should be able to run Angular without RxJS. That's really the plan. But there are places where it's going to be more tricky to replace it, such as the HTTP client, because it's asynchronous, and RxJS is still really good for all things asynchronous. So we'll see. But in the future, what I can tell for sure is that there's going to be less and less observables in Angular. It's going to be more and more signals. So that's why I like to do these workshops and these talks, to really get everyone prepared for the future. And if you get into signals right now, it's really the time to get started, because it's only going to be more and more of them in the future.
Yeah, that's awesome. There's a follow-up question. It's coming from me personally, to be honest. Is there an easy way? Because I worked in the past in an Angular-based application, but it was a huge application. My question is there an easy way to translate from observables to signals in like one shot, or like code mode or something?
Not quite yet. Now, people would probably say, there's a two-signal function. So you just apply two signals to your observables, and then you're good to go. Which is
right?
true to some extent, right? Because there's still the catch of what happens before you get the data and having an initial value or not. And this can be tricky. That's what we have in terms of tooling so far. The benefits is that it's super simple. You don't have to learn tons of things. Once you know about two signal and using an initial value, you know pretty much everything you need to know. So that's good. But yeah, I think we can imagine in the future that the Angular team would create a schematic for an automatic migration.
Oh, yeah.
They've done it for many things so far, like removing modules to switch to standalone components. They did it for the new block syntax for the for loops and everything. So why not to use two signal? I think it's
just too early.
Yeah. So we'll see.
Yeah. But yeah, that makes sense. I was asking the question because it was scattered everywhere using observables, and it's painful to do that manually everywhere. So maybe in the future, some schematics or something. Yeah, that's a really good answer. So the last question we have is, do you have any cool use cases that you have found become a lot easier with signals?
Well, this one, the same thing with observables was really messy and complex, because the thing is, once you want to handle any sort of complexity with observables and combine different streams, you have to use operators. And operators in RxJS are very powerful, but there's many of them. There's literally over 110 operators, I think, in RxJS. And so the question is always, which one do I use? And sometimes you use one, and then you realize, oh no, other people are going to tell you, no, that's not the one to use in that scenario. You should use this one. And then you'll find a blog post where they use the third option, and that created complexity, because what to do? What I really like about signals is that the 100 plus operators are replaced with this, computed. So every time you used a map, a switch map, a tap, a whatever in RxJS, now you just use computed, and it does pretty much the same thing. It automatically understands that you're trying to access values from different signals, so different observables in the past, and you can automatically combine these things in a new way. So just that syntax is extremely powerful, and replaces lots of operators and subjects and all of that stuff is now completely gone and really simplified. So to me, that's the most beautiful in terms of simplification that you can see really. Computed makes life so much easier.
Yeah, that makes sense. Indeed, that's kind of, it's not a workshop, it's a crash course actually in signals. Thank you very much, Alain, for everything you explained. It was really awesome. And if you have any final word you would like to leave for the people who are watching you and following you.
Yeah, so if people have questions about this, feel free to reach out to me. You can find me on LinkedIn, on Twitter. You can just Google my name, find my website. I'm always open to answering any questions. So feel free to reach out. Always happy to help. That's what I do for a living. I teach Angular. I talk about Angular. So always happy to do it more.
Yeah, that's awesome. Thank you very much again, Alain Chautard. That's what you told me, right? All right. Thank you very much for being here, and until meeting you in another conference, hopefully.
Sounds good. Thank you. Yeah. Bye.
Peace.